Dear students, I am Professor Satish Thorat from Mechanical Engineering Department, Sanjeevani KBP Polytechnic, Kopargaon. In last lecture, already we have started the Unit 1 of this course, that is Moment of Inertia. In last lecture, we covered the topic concept of centroid and center of gravity, positions of centroid for standard geometric sections, and the concept of moment of inertia. In last lecture, we understand that the moment of inertia of an area is the capacity of a cross section to resist bending or buckling. Now, in continuation with these topics, in today's lecture, we are going to see the moment of inertia about the axis passing from the centroid. Then we will go with parallel axis theorem, then perpendicular axis theorem, and radius of gyration. Now, first we will see the different formulas which are required to solve the numericals of moment of inertia about the composite areas. For that purpose, we required the formulas of moment of inertia for simple geometric sections. In the last lecture, we have seen the formula or position of the centroid for these simple geometries. Now we will go with the moment of inertia about the axis passing from the centroid for simple geometries. Now concentrate on the first geometry, which is the most required geometry in this unit, moment of inertia, that is a rectangle. Here there are two centroidal axes, that is centroidal axis xx and centroidal axis yy, as these are passing from the centroid. First we will see the formula to calculate the moment of inertia about the xx axis, that is ixx. Now if you concentrate on the formula bd cube by 12, the simple logic behind this formula is when you are going to calculate the moment of inertia about the x axis, first you have to take the side which is parallel to the x axis, that is b. Here is the b. Then you have to take the cube of the remaining side. Remaining side is the d, bd cube by 12. Similarly, you have to apply same logic when you are going to calculate the moment of inertia about y axis. See, y axis. The parallel side to this y axis is d. D come first, then cube of the remaining side, that is b cube divided by 12. This one is the logic behind this formula of the moment of inertia for the rectangle. Now for circular section, the centroid lies at the center, and if you see this distance, that is, it is the radial distance of the area, and it is equal. So moment of inertia about x axis and y axis are same, pi d raised to 4 divided by 64, where d is the diameter of the circle. Now when you are going to calculate the moment of inertia about the triangular section or triangular area, at that time you have to concentrate on the three main concepts of moment of inertia. Here we require moment of inertia about the centroidal axis xx. Then we require the moment of inertia about the base, that is bc, and we require the moment of inertia about the apex, that is point A. When you are going to calculate the moment of inertia about xx, simply you have to use the formula bh cube by 36, where b is the base of the triangle, h is the height of the triangle, basic dimensions of the triangle. When you are going to calculate the moment of inertia of this area of triangle about the its base, that is bc, you have to use the formula bh cube by 12. Again, b is the base, h is the height. of a triangle. And when you are going to calculate the moment of inertia of this triangular area about this apex, then you have to use the formula BH cube by 4. BH cube, BH cube is the common term, only the denominator is changing, and you have to do it by heart. Now all these are about the formulas of moment of inertia about the central axis for some common geometries. Now we will see the parallel axis theorem. Whatever the formulas are available for this simple geometry are available for the axis passing from the centroid. But when it is necessary to find out the moment of inertia of an area with respect to any axis other than the centroidal axis, but parallel to the axis, then you have to go with parallel axis theorem. Now, how you are going to use this parallel axis theorem? First, we will understand the statement and then we will go with its mathematical expression with the help of diagram. What parallel axis theorem states? It states that the moment of inertia of a plane section about any axis parallel to the centroidal axis is equal to the moment of inertia of the section about the centroidal axis plus the product of the area of the section and the square of the distance between the two axes. Now we will understand this statement with the help of this diagram. The moment of inertia of a plane section about any axis parallel to the central axis. If you see this diagram, this AB is the axis which is parallel to this central axis. This GG is the central axis and AB is the parallel to the central axis. And we want to calculate the moment of inertia about this parallel axis AB, that is IAB. Parallel axis is equal to, see this symbol, is equal to the moment of inertia of the section about the centroidal axis, means the moment of inertia of this area about the centroidal axis, that is IGG. This one is the IGG plus this plus the product means multiplication of the area this area of the section and the square of the distance between these two axes. H is the square between the axes. This one is the mathematical expressions, and we are going to use this mathematical expression while solving the numericals on moment of inertia of composite areas. This is all about parallel axis theorem. Now we will go with the perpendicular axis theorem. Now what is this perpendicular axis theorem? When you want to calculate the moment of inertia about the perpendicular axis to the previous both axes, then you have to go with the perpendicular axis theorem. What this theorem states us? This theorem states us that if Ixx and Iyy be the moment of inertia of the plane section about two mutually perpendicular axes, then the moment of inertia Izz about the third axis Zz, which is perpendicular to the both axes xx and yy, then it is given by Izz, that is moment of inertia about the zz axis is equal to moment of inertia about the xx axis plus moment of inertia about the yy axis. Now concentrate here. This one is the mathematical expression. Izz is equal to Ixx plus Iyy. Now we will understand this mathematical expression with the help of this diagram. See, this one is the area A. Now this one is the x-axis, this one is the y-axis, and this one is the z-axis, which is perpendicular to the both x and y. Now if we calculate the moment of this area about this axis, that is Ixx, this area about this y-axis Iyy, and if you want to calculate the moment of inertia of this area about the mutually perpendicular axis z, then there is no need to calculate separately. Simply you have to add the moment of inertia about the Ixx plus moment of inertia about the yy, that is Iyy. This one is the expression. Izz moment of inertia about the zz axis, Ixx moment of inertia about the xx axis, Iyy moment of inertia about the yy axis. Now sometimes this perpendicular axis theorem is also treated as polar moment of inertia. Why? Now, when any object is in the space, at that time, to locate its position, we required three axes, that is axis x, axis y and axis z. At that time, this zz axis is called as polar axis. Hence, in this case, this perpendicular axis theorem, that is Izz, is treated as polar moment of inertia, and it is represented by Ip. And to calculate polar moment of inertia, you have to use the same formula Ixx plus Iyy. This is all about the perpendicular axis theorem or polar moment of inertia. Now we will see very important concept from this moment of inertia, that is radius of gyration. Radius of gyration about any given axis is defined as the effective distance from the given axis at which the whole area is supposed to be concentrated. Now see, this one is the total area and this one is the axis of rotation. We require this distance. If you take this point, this distance is r2, this distance is r1, this distance is... Now which distance we have to take while calculating the moment of area? For that purpose, what we are going to do, we are going to consider this total area is concentrated like this, and we are going to consider this distance of this total concentrated area from this axis of rotation as k, that is the effective distance, and this effective distance is considered as radius of gyration. Mathematical expression to calculate the radius of gyration is simply you have to take the square root of I divided by A, where I is the moment of inertia about the central axis and A is the area of the cross section. As radius of gyration K is the length, its SI unit is mm. This is all about radius of gyration. Now, whatever the content we have covered in lecture number 1 and lecture number 2, all these are the theory concepts which we require to solve the numericals of moment of inertia. Now, in next lecture, we will go with the numericals on moment of inertia. Thank you.